At long last, we learned how to do the ANOVA test, and we will get there at the end of the video, unfortunately. But again, the ANOVA test comes up in the circumstance where we're testing the means for multiple groups, multiple meaning more than two, okay? And we have to have a quantitative variable, and so when we, you know, set up our null and alternate, here's actually the format that we're going to follow. We're going to have the null as all of them are the same, all of the means are the same, and then the alternate, we don't really write it symbolically because it is difficult. We don't know which ones are not equal, so we just say one of the means, mu I, is different, and then I is just an index that can represent any one of the indices. Okay. Um, when we do this test, just be aware that because we're looking for difference, it is not implying a direction. It's not saying one mean is bigger than the other. Okay, that would have to be done in a follow-up analysis. Okay, and we also know that when we are doing this test, we're trying to account for the variation within a group, within a population, and between populations. And so the some details about the test are that behind the scenes, what's going on is that this test is computing an F statistic, and that F statistic is computed as the ratio or as the variation among the sample means. This is called the mean square error for groups. So this is between two groups, and it's dividing that by the variation among individuals in the same sample, so within a population. We call this the mean square for error, okay, MSE. So it's taking MSG, not to be confused with let's send food, divided by MSE, okay? And how you calculate those, if you're interested, go to your book, go to Google, wherever, look it up. It's involved, but it can be done. Okay, and you will not need to be able to compute the MSG and well, okay, you will need to compute MSG and MSE by hand, but I could say MSG is this, MSE is this, divide them. There you go. Okay, and when we look at the F statistic, it is called the F statistic because it comes from the F distribution. And here's a few F distributions shown. Okay, the F distribution, it's right skewed, meaning as most of this data is clumped to the left and it has a long tail to the right. When we talk about this distribution, it's not like the normal distribution where you provide well, I guess it is like the normal distribution in that you provide two parameters and it completely determines the curve. The two parameters here that you provide are called degrees of freedom, and there's the two values are computed by down here. Okay, I'll get to some of the other bullets here in just a moment. Okay, the first degree of freedom, okay, it corresponds to the number of populations that you have. It's from the numerator. So when we're looking at variation among sample means among groups, right? How many groups do you have? However many you have, that's your -1. That would be your first degree of freedom. So numerator is k-1 if you have k groups. And then the second degree of freedom corresponds to the denominator, which is variation among samples, individuals in the same sample, okay? And the way we calculate this is that we determine the total number of people sampled in all, and then subtract the number of groups you have, okay? So the second corresponds to the denominator, and that's going to be n minus k. And so then, you know, in this first one here, it would say, if we look at f of 230, that means that there's two groups, right? And then there would have been 32 individuals sampled. If you go back and kind of go backwards, okay? Nevertheless, degrees of freedom, they are important. The other thing that I want you to be aware of is that if you have to be able to understand the F statistic, okay? So let's say we do MSG divided by MSE, we get a number. Okay, what's that mean? How do we get a p-value from that number? Okay, so the idea would be, here's your F statistic. Okay, I'm just going to draw a line. Since it is right skewed, how we calculate the p-value would be from our test statistic and everything to the right. Okay, and so if we have a large test statistic, so let's say, okay, instead of it being over there, let's say it's out at say 50, okay, which is okay. You do a little break in the graph, and you're all the way out at 50. There's not going to be a lot of area. There's not going to be a lot of remember again, to determine the probability, to determine the p-value, would be the area under the curve after our test statistic. Okay, there's like nothing after 50. So that means our probability is going to be very, very close to 0. Okay, and so the main takeaway here is the larger the test statistic value, the smaller the p-value should be. Okay, further away from 0 you are, the smaller the p-value should be. Okay, so that's all nice and well. This is all very theoretical. How the hell do you do this damn thing? Okay, I have been dodging that question. I am going to answer it now. Okay, we're returning to our example from the anthropologist. Okay, and previously we had made this beautiful chart, right? And we said, yeah, it kind of looks weird, like at least between the Asian population and the Black population that was sampled, there's some differences going on. So let's confirm or disprove that with a test. Okay, so first of all, when we do this test, you will need the data sorted according to your different populations. So this data that I have here, this is wonderful. Okay, I want to work with that data. Okay, and I'm just going to zoom out a smidge so I can see the entire thing. Okay. To do the ANOVA test, once we have our hypotheses set up, great, go into the data tab on Excel and go into our lovely data analysis tool pack. Here it loads. Okay, and we're going to go into ANOVA single factor. That just means we have one explanatory variable. There are obviously other types that we're not going to study in this course. Stick to single factor. Okay, now it says input range. Okay, highlight the data. All of the data sorted by columns, right? So it says group by columns, so it knows how to read the data. And then we need to select our output range, go in there, select a random place in your cell, in your worksheet, click OK, and you get a big table. Okay, the first table is actually kind of helpful because it tells you, how many are in each sample, the sum of those, but I don't know why you need that, and then the average and the variance. Okay. I would argue that eventually knowing the standard deviation will be more helpful. We'll get there soon though. Okay. And then now the second table is gold. This is what we want. Okay. So notice that it says source of variation between groups. So SS, I don't know what that is. It's actually sum of squares. Mean square. Okay. So this is mean square between groups. So this is the MSG and this is MSE. And if you wanted to say, divide those, take MSG divided by MSE, you get our test statistic. Okay, so that's our F test statistic. And then to get the p-value, you would follow it there, or you can just do f.dis.rt, and then you would do the F statistic to first degrees of freedom, second degrees of freedom, and you should get the same thing. Yay. And that's our takeaway. Okay, so very, very small p-value, meaning, and if we look at the test statistic, it's like 50, right? So it makes sense. Like there's like no area to the right of 50 under the curve. So we did the statistical test, provided conclusion. The conclusion would be, and I'm just going to type this out, since P is approximately 6 times 10 to the negative 18, which is less than 0.05, which is alpha. Oops. We reject the null. We reject the null based on the data. There is sufficient evidence that the means, oh goodness, that the mean heights, that at least one population has a different mean height. Boom, done, drop the mic. But really that's it. Okay, so you can see Excel does a lot of the work for us. All the work, in fact. We just need to be able to interpret it. Okay, now in practice, this is not where this would end. Once you reject the null, you need to, do that follow-up test. Or do the follow-up analysis. What do you do then? We're not going to get into that in videos, but in class we will be doing a series of t-tests and visualizations like what we have done in this chart. Okay, so more to come on that, but for now we are done with knowing how ANOVA works and how to do it.